Hello students, so today we will discuss the derivation of the law of refraction from Fermat's principle. In the last video, I have already proven the laws of reflection from Fermat's principle. So before watching this video, I would like to request all of you to go through the note that I have uploaded in the Google Classroom. It is put under the section applications of Fermat's principle. So for that we will consider a simple diagram. So I will try to draw it. So the diagram is also drawn in the note. You can see for your reference while watching this video. Suppose that you have a point A, and the point from the point A, rays of light are coming out in all the direction. So we will be considering one ray of light like this. Okay, so it is not at all a straight line as you can see in the screen, but it is actually a straight line. Ray of light always moves in a straight line. And my suggestion is that whenever you draw by yourself, use a skill and pencil. So now this is a ray of light and it is incident on a particular surface. Okay, and that surface is PQ. And what is the speciality of the surface is that it separates two medium. Okay, so this medium, the medium on this side has a refractive index of N1, and the medium on this side has a refractive index of N2. So these are the two refractive indexes. So you know that when the ray of light is falling on a surface which separates two medium, then what happens? The refraction occurs, isn't it? So the ray of light is supposed to be a straight line like this, but since it has encountered another medium, so it will be coming like this, isn't it? So the ray, let me make it little clearer, sorry. So the ray of light is coming like that. It is falling on this surface PQ. So if there is no medium, it was supposed to be like that, but actually since it has encountered this surface between two media, so it will deviate from that line. Okay, so it will look like this. Okay, so it will go away like that. Okay, so let me draw a normal here. Okay, normal at the point of incidence. Okay, so I will try to, yes, so the ray of light is coming like this. Fine. So this dotted line is actually not followed, so I will remove it. Okay, so this is the thing we have now. What we will consider, say this is equal to theta 1, okay, and this is equal to theta 2. Fine. So yes, now this is, let me introduce this point as B. Okay, and what I will do, I will introduce this point as R, and this point, now I will drop a perpendicular. Okay, I will drop a perpendicular from A on the surface, on the plane PQ, on the surface PQ, and it will, this point I will name it as M, and this distance is basically called small x. Okay, and I will call this whole distance. Okay, again from B I will drop another perpendicular like this. Okay, and this one I will name as N. So this two distances is nothing but capital L. So this distance, okay, this distance will be L minus x. I hope you are fine with the diagram. Okay, so this is a refractive index N1, this is a different medium N2. Now we have the diagram. Now you see, you can see that a ray of light is coming out from the point A, then intersects at the surface PQ at the point R, and then proceeds towards B along RB. Now clearly for minimum optical length as per Fermat's principle, the incident ray, the refracted ray. So incident ray means AR. So incident ray AR, and then you have the refracted ray what is that, RB. Okay, and the normal at the point of intersection must lie in the same plane. Okay, so the normal, I have not named anything to it, so it's a normal drawn at the point of incidence. So what is the point of incidence? It is called R. All lie in the same plane. Okay, so that's what we got. Now to determine the point R, now you see this ray of light is coming out of here and coming up to R and then going to B. So just consider there may be another point like this, isn't it? And it may also come like this. There may be another point like this, it may come here. So why have we chosen only this one? Why we have chosen only this one? Okay, so that means if the path ARB, okay, is the correct path, that means it should be the minimum path. Okay, minimum path length, or you can say the minimum time taken through this path. So we need so that means if the ray of light is definitely coming to the path ARB during the refraction, it must be the minimum path. Okay, so that is suggested by the Fermat's principle. Okay, so let me remove the unwanted part again. So this is not required. Then here also I removed. I will draw the diagram again to make it clear for you. So again it is coming like that. The ray of light is going like this. We have dropped a normal like this, and here also, and this angle is theta 1, and this distance is I am naming it L minus x. And another we will describe some other angles. Suppose that if this is theta 1, this angle is also going to be theta 1. It's very much clear because these are alternate angles. So similarly, if this is theta 2, this is also going to be theta 2, because you know that this normal and this BN, they are parallel. This is and this is parallel. Similarly, you consider AM and this normal is also parallel, so they will be equal. So there should not be any doubt about that, I think. So these are simple geometrical principles that we usually use. So let us do some geometry. So as I said that to if you really want the image to be formed at the point B, and if this is a real path followed by the ray of light, then the path ARB should be the minimum one. Okay, so that's all we have. Now let us determine, that means it is equal to optical path. Okay, so I will name it as L suffix optical. You can see in the note that I have provided. Okay, so L optical, that is nothing but, I will tell you, AR plus RB, because L optical is nothing but the total path ARB. So that is nothing but AR plus RB. Now you can see that this AR is in the medium N1, so we need to multiply it by N1. And you can see the path RB is in the medium N2, so we need to multiply it by N2, because it is not a homogeneous medium. We must take into consideration the refractive index. Now we will use some means normal mathematics that we know. So AR, look at the diagram AR. So if I consider AR to be the hypotenuse in the right angle triangle AMR, so AR is nothing but, according to Pythagoras theorem, it will be nothing but AM square plus MR square. Am I correct about that? You just check. Similarly, N2 into RB. Now look at RB. RB is the hypotenuse of the right angle triangle RNB. Okay, triangle RNB. So there it will be, according to Pythagoras theorem, again it will be equal to BN square plus RN square. Okay, we know about that. Now you see, let me remove those curly brackets again. These are not at all necessary now. Now again, in the diagram that I have provided, this distance is basically named as H2, and this distance is named as H1. Okay, so AM is nothing but H1. So AM is H1 and BN is equal to H2. Again, you know that here MR is equal to X and RN is equal to L minus X square. So you can take a pen paper and try to solve it. Okay, so AM square means H1 square and MR square means X square, plus N2 into, you can see BN means H2 square plus RN means L minus X square. Okay, so let us write it down simply. So L optical is equal to N1 into root over H1 square plus X square plus N2 into root over H2 square plus L minus X whole square. That's all we have. So let us name it as equation 1 for this section. Okay, now if you want to minimize, so to minimize L optical, okay, as per Fermat's principle, what should be the condition? We have written integration should always be equal to 0. So this is nothing but the total length. So here it is actually L optical, okay, equal to 0. So we will, since we are talking about the variable distance is nothing but X, we are considering in that dimension only. So we will write it as d dx of L optical is equal to 0. So d dx of L optical, so L optical values you know, N1 root over H1 square plus X square plus N2 into root over H2 square plus L minus X square. So that must be equal to 0. Now if I go inside that differentiation, obviously you know that this is nothing but 2 power H1 square plus X square whole to power half. So it will come up with 1 by 2. Okay, then H1 square X square half minus 1, isn't it? So it will be equal to twice X plus N2 into, I will write it down in the next step, plus N2 into 1 by 2 H2 square L minus X whole square whole to power half minus 1 into, again it will be twice X. Okay, So it is 2 into L minus x, and there will be a minus sign, isn't it? So that is equal to 0. I am not going to define you the differentiation. So you can see 2 gets cancelled, and here also 2 gets cancelled. So what remains? n1 into x divided by h1 square x square root over, then again we have minus sign, so it is n2 into L minus x root over L minus h2 square plus L minus x whole square equal to 0. Okay, now if you go back to the figures, now you can see that if you go back to the figure, yes, so in this figure I would like to remove these things because we have already done it. You might have taken note of this, and you also have the note along with you. So now what we will be doing, let us consider sine theta 1. So if we consider it in the triangle, AMR, okay, then sine theta is nothing but perpendicular by hypotenuse, isn't it? So hypotenuse is nothing but h1 square plus x square, and perpendicular is nothing but x, so it is sine theta 1. So x by root over h1 square plus x square is nothing but sine theta 1. So this thing is sine theta 1. Similarly, if I go back to that, so from triangle BNR, sine theta 2 is nothing but again perpendicular by hypotenuse. So this time also hypotenuse is nothing but h2 square L minus x, and here also the hypotenuse is L minus x. So in this place we can write n2 sine theta 2 is equal to 0. So we can write n1 sine theta 1 is equal to n2 sine theta 2. So sine theta 1 divided by sine theta 2 is equal to n2 by n1. So this is nothing but the Snell's law of refraction. Snell's law of refraction. Okay, and this is the second law of the refraction of light. So you can see that with the help of Fermat's principle also we can prove the laws of refraction of light. So that's all for today. I hope you have understood it well. If you have any kind of doubt regarding this derivation, you are free to discuss your doubts with me either through WhatsApp or through email. Thank you.